Okay, so we are looking at the question where this is an integration. I mean, this puts together certain topics. It also puts together the application of differentiation, where we need to find the equation of a tangent normal. So it's basically find the equation of the normal, because the line PQ over here is the normal to the curve. So we are finding the equation of a normal based on this. And after that, given that we know this point, we're supposed to find the area bounded by the curve, the y, PQ and the axis. Okay, so next, what do we do is, okay, because here, right, PQ is normal to the curve. I want to find the equation of PQ, right? So you want to find the equation of a normal, then of course the basic thing is that we need we need a point, and we need the gradient, right? So example, one idea is I can either find P or Q, and I also need the gradient over here. Now, how to find the gradient? Here, the hint is that, well, we are looking at normal, so the gradient to this line, if I want to find a gradient, the only clue I can get is I can get it from the curve, because if I can get a gradient of the tangent here, I can also find the gradient of the normal here, okay, so that's how I'm going to go about finding the gradient of this normal line, by using my y. So I know that one thing is that this point over here, at this point, is basically x equals to 3, right? X equals to 3. So this is 3 comma something. What is it? Well, all we need to do is we take y, we sub x equals to 3 into y equals to x squared minus 4x plus 5. Okay, and what you get is basically, after that you get that y is equals to 2. Okay, so basically your point P, right, is just 3 comma 2, right? 3 comma 2. And that, so you see I have a point on the line PQ. What else do I need? Is I need the gradient. How to find gradient? Simple. We take our function, we differentiate it, dy dx equals to 2x minus 4. And from here, okay, I want to find the gradient at this point. What I can do is I just sub in, sub x equals to 2, because remember, when we sub x equals to 2, what we're doing is we're able to find the gradient at this point, okay, and at least the gradient of the tangent. And I take negative 1 over that answer, that will give me the gradient of the normal. Okay, so substituting x equals to 2, the gradient at the point x equals to 2 is basically 2 bracket 2 minus 4, and that gives you, oh sorry, x equals to 3, okay, not 2, yeah, x equals to 3, and I have 2. So gradient of the tangent here, right, is equals to 2. So what is the gradient of the normal? Right, I'm sure you know the gradient of the normal must be equal to negative half. I just take negative 1 over the answer. And so you can see that in order for me to solve for the equation of this line over here, right, I have a point, I have a gradient, and I am able to solve for the equation of the PQ, or the normal line. Okay, and with that, I go on next. I just use the equation. If you find the equation of a normal, I know use that y equals to minus 1, negative 1 over the gradient, then x minus x1, okay? So I'm just going to sub in y minus 2 equals to negative half x minus 3. And you can show that this will give you 2y plus x equals to 7. Okay? Now next, the thing is, now I want to find, given the equation, so I'm done with this part. I'm so done. Okay, so find the area of the shaded region, okay, bounded by the y equals to x squared minus 4x plus 5, okay, as the line PQ and the axis. So I basically I'm going to find the area of this. The strategy, I'm going to find the integral by using integration formula from here to here. And for this region over here, I'm just going to use area of triangle. Okay, so I know that for this part, right, the coordinate is basically 3 comma 2. So it's also saying that this part over here is 2 units, and this part over here is 3 units, right? So finding the area of this triangle is basically just half times base times height, okay, or PP1Q. Okay, so half times base times height. Okay, Oh, wait a minute, it may not be true. I am so sorry, I made a mistake here. This may not be 3. Alright, so in order to find the length correctly, I know that this part is 3, this coordinate is 3. Okay, I need to find what's the coordinate of q. So q here basically is when y equals to 0, and you can observe that if I were to substitute in, right, y equals to 0 here, that means x equals to 7. So here at q, x equals to 7. So the units over here is basically 4 units. Alright, 7 minus 3. So if I talk about the area of triangle P1Q, this is like half times base times height, okay, which is a 7 minus 3. Alright, and the answer turns out to be, half times 2 times 4 is just 4 units square. Okay, now next I'm going to look at finding this area here. Now this area is not difficult to find. This is nothing but the integral from 0 to 3, x equals to 0, x equals to 3, x squared minus 4x plus 5 with respect to x. Now solving this, okay, I'm sure you are able to do it quickly. 1/3 x cubed minus 2x squared plus 5x integrate 0 3. Okay, and you have from here you should be almost done, and you get your answer to be 3 to 0. Let me see, what do you get from here? The answer should be equals to 6 units as well. Now obviously I made a careless mistake earlier, so this answer over here is actually 6, not 4. So if I take 6 plus 6, my answer will come out to be 12. Okay, so the total area of the shaded region would be equals to 6 plus 6 to be 12 unit square.